we go. You can all see this. I guess I'll just do a little intro. So for those of you who weren't here, my name is Vlad. I'm the IEEE uOttawa Student Branch Chair, and I'll be your instructor today for ITI1120. So today we're going to be reviewing mostly end of term materials. I'm assuming that all the basics have already been covered, by later assignments, and you should pretty much already be familiar with that. So we're going to basically focus on classes and recursion and exception related stuff. But if there's any questions for anything after or anything outside of this, then please let me know and I'll do my best to answer them. Oh, I think it did do something. Yeah. Oh, there we go. Okay. Just makes my screen tiny. My res. Well, let me see if I can extend that.
You should be able to.
Displays. We just stop mirroring. Yeah, there we go. Alrighty. So let me just pull that up.
Hey.
Hey, how's it going? We're about to start.
Yeah, you can just sit over there.
Okay.
For 1120 or 1106. 1106.
Okay, we're just away.
The presentation for 1120 is going to be on the projector. For 1106, we have someone coming in and they'll be giving help on that one.
Alrighty.
We got someone for 1106.
Oh, that's cool. You're still here. Oh, I didn't even get to see that CSSA.
Alrighty, guys. Just 2 more minutes and we'll get started. Okay, can everyone see my screen? Right.
You have any specific topics in mind or concepts you need to go over? The thing is with this course specific, we're not expecting that big of a turnout because for this course, you change over the 6 specifically, we're not expecting that big of a turnout. Yeah, it's probably going to be just me explaining concepts from our own.
Remember, the cookies are in.
Hey, how's it going?
So please say your report. 106. Awesome.
Awesome. Yeah. Yeah, I think it might. It'll be interesting.
Ricky, I just want to make cookies.
Oh, no problem.
All Alrighty, let's get started. Can everyone hear me? Okay, if there's at any point like a clash between, okay, wait, hold on. All right. Just fixing a bit of logistics here. We'll be on our way in a sec.
So if anyone shows up for JJ06, tell them.
Tell them, I'll tell them, have some cookies and then go to the CSS. Oh, yeah. Did you did they grab cookies?
No, I think you're the one who grabbed the cookie.
Do you know the room number for the CSSL?
It's just all, it's, I
I
don't know.
but I just think they might not know which CSSL.
I will leave them there.
Okay.
Can I have some cookies to take for them? We have a box or container we can put them in. Okay, let's run it in. Good luck.
Thank you. Alrighty, guys, let's get started. Okay, so like I said, it's going to be later topics. These include mostly, classes and recursion, and a little bit of exceptions. So here's what we're going to go over. Here's a little review for classes and this session. First, we're going to learn how to define a class. Then we're going to talk about overloading. There's designing container classes, inheritance, creating your own custom exceptions if you need to. We got the basics of recursion, and then we got some examples. And then after this slide, we're basically going to go through some code examples, and I have a few questions that we're going to solve together. So first up, we got creating a class. So here's the classic example. It's the point class. I believe you guys have seen this in class. But if not, the point of the point is you get to set the X and Y coordinates. You get to get those coordinates, and then afterwards you can move it. So you can move it by, any change in coordinates. Okay, so here's how that would look coded up. So you'd have define. First of all, you'd have your class. So to define a class, you just do class and then the name. And in Python, usually the class names always start with a capital letter. After this, we define a set X. This sets the X coordinate, self.x equals X coord. In Python, whenever you have an object or a variable that belongs to the class, so you have, you have a variable, you have to use self to make it so that it's an instance variable. And then you have self.y equals y coord for set y. And then when you get, all you do is return self x and self y in a tuple. To move it, you would have self.x plus equals dx, so that's the change in x, and then self.y plus equals the change in dy. And here you don't have any returns because you're not actually returning any value. You're changing the value of the instance variable, and it doesn't really return anything. So here's the usage. Here's how you would use it. You do a equals point. So you define the object instance. You have the point right here, and to define the instance, always make sure that you have two regular brackets, two circle brackets, and that creates the object. If you don't have this, you're going to say a equals the class point, which is not what you want to do. Then you do a.setX, a.setY, and then when you get those, it returns what you just set it as. Pretty simple. Oh. All right, so what if we wanted to initialize a value? You have a equals 0.34, but if we looked here, there's no init function, so we're not able to do that first. And so to do that, you have to overload. And here's how you would overload. Classes always have, these functions that are built in, and these are built into basically every class. And one of those functions is the init function. And usually the notation for these built-in functions are 2 underscores on each side. So you have def, you define init. Yes, Jaden? Overloading versus overriding. Same thing, just different word. You can call it overriding as well. I actually had a Kahoot question last year where I thought they were different. And then someone corrected me, and apparently they're the same thing. So here you're overloading or overriding the function. Here you have init, and that means that you can basically initialize the object with points already there, so that you don't have to do set X and set Y. And this basically does the same thing as those previous functions that we made, except it's when you initialize it. So init is called every single time you initialize a class object, even if you don't override or overload the init function, it always has one. And so that's why here you have the brackets. So this is basically saying you want to initialize it. Alrighty, so then we have container classes. Container classes basically, it's another form of a class that contain, information as well. So container classes usually have arrays inside of them. And in here, as you can see, this is a deck of cards. We have the ranks, which is, this constant array. And then we have the suits. These are the Unicode symbols. Then we have the init function that we're overriding. Self.deck equals array. And so the deck is initially empty. And then while you initialize as well, you add every single available card combination into the deck. So this goes for every suit that is found in deck.suits. And for every rank in deck.ranks, you basically append every single combination of every single card into the deck. And so this initializes your container. And so here, as you can see, we use deck.ranks with a capital D. This is not to be confused with this deck right here. They're two different things. Python is case sensitive. So this deck and this deck are different. And so this capital case deck is referring to the class itself. So if any of you have ever taken Java or you've learned Java, this would be kind of like static variables here and static information. So next we have the deal card, and this does self.deck.pop. So this takes the deck. Yes, Jaden, you have a question? Will it append randomly each time when accessing those sets? No, it won't. So every single time it goes for suit in deck.suits. So it'll go in order with this first one, U2660, and then it'll add all of these numbers for this one. And then it'll go over one to this, add all these numbers, over to this, all these numbers. And so that's why we have the shuffle here. In your initialize, if you really wanted to have it random every time you initialize, you would just do, you would shuffle right after you create this. And so that would give you a shuffled deck. But automatically, it doesn't do that with this code. Does that answer the question? All right, cool. And so here we have shuffle, and shuffle comes from the random package. And this basically shuffles any kind of container, any array that you may have. So what happens if we write length of a deck, and this deck is an initialized new deck? And Andrew, if you have the answer to that, you can. Exactly. So it would give you an error. It would crash the code. And this is because we need to overload or override the length function. And this is also a built-in function, hence the two underscores right here. So all you would do here is return the length of self.deck, and self.little lowercase deck is the array itself, and that contains its own length function. All right, so here's a few, but not all, overloadable functions. So you have addition, subtraction, multiplication, true division. You have floor division, which is integer division, your modulo. And then most commonly, I'd say we use str, repr or representation, and length, as we saw above there. So what about inheritance? And so here's another classic example that you guys may have seen before. Little refresher. This is the class animal. And so animal has its own species, species variable. It has the language, or what the animal says. And then you have the speak function, which prints out I am a something and I something. So if you guys haven't seen this before, the dot format in Python, you can add that after a string. And then for these curly braces, you insert whatever you want to put there, and it inserts that automatically so that you don't have to use, string plus string plus string. This is kind of an easier way to do that. And so speaking would print out this string right here. And so a bird, you can inherit the class animal inside of the bird, and then this would represent a bird. And so from here, you can overload or override the speaking. So instead of this right here, instead of saying I am a something and I something, you could say, you could just do something else. So in this case, it prints out, the bird sound. Self.language, which is something that you set earlier on. And then it does that 3 times. So if it was a bird, it could say something like chirp, chirp, chirp. Next up, after classes, we have custom errors, which are actually classes that inherit the exception. So here is an example of empty queue error. This is a custom defined error. It inherits exception. It doesn't really do anything on its own because the exception already has basically some functionality already in it. And so here, if your length of your queue or doubly ended queue, oh no, this is a regular queue. If that is empty, if the length is 0, then you could raise this error. So errors aren't returned. They're raised, and then you basically put the message that you want here. And this makes it a little bit easier to debug. So if you're coding, you always want to make sure that you have these specific errors instead of random stuff, or just saying, I want to raise a regular exception. Although you can put this string into a regular exception, it does give you a little bit less a little bit less information. And so it's always good. It's always good to make your own errors if you need to, and if they don't exist yet. And so these are raised, again, never returned. So here's the usage, and here's what that looks like. So you create a queue. By default, it has 0, and you try to dequeue something from the queue. And right here, you see the error is raised. It's an empty queue error. And here's the message that we included here. That's again shown here. And then here's a prettier printed way. So this is how that would look like. And so it's better to use stuff like this than again using an exception, because it just gives you more information. You see empty queue error and you're like, okay, I know exactly what's going on. Next up, we have recursion, probably the trickiest topic in the class. And recursive functions are basically functions that call themselves. It's like a big game of telephone. The function calls itself, which calls another function, which is itself, and then it goes back and forth all the way till it hits the bottom, and then it does something and goes all the way back to the top. And so you need two main components in recursive functions. You have your base case, which tells your function when to stop, and you have your recursive step, which basically happens when it calls itself. So when the function, calls itself. So here's an example of a recursive function. This does a countdown. What's missing here? Or is nothing missing at all? Yeah, exactly. The base case. So it won't run forever because there's a point where you can't print n-1 because it's too big of a number or too small of a number. But it goes up until then, and then it would crash. So here we would have to add a base case. So we say if n is less or equal to 0, then you print blast off. Otherwise, you print the number and then you call countdown n-1 again. Actually, before you would run out of numbers, you would you would get another error. Does anyone know what that error would be? No, it won't be an out of range error. So what would happen here is you would hit the recursion limit. And so you'd have the maximum recursion depth exceeded error. And if you've written any recursive function, you've probably seen this before, unless you've just never forgotten to add a base case. So here we added the base case, like I said, and here's an example. So print digits vertically, recursively. And so we'd call vertical 3124, this is an integer, and it would print digits vertically. Here's the code for that. So we have def vertical, n is your number. So n here would be 3124. If n is smaller than 10, then we print n. Otherwise, we call the function again with n integer division 10. So that gets rid of, it gets rid of the first number. And then we print n modulo 10. So that, that would print the number right here. All right, so that's it for the slides. Are there any questions? Anything I didn't mention? Repr versus str. Okay. We can actually go and check that out in Python. I'm going to open up my IDE here and we can play around with that. Stop sharing my screen here. You haven't learned recursion yet? Okay, perfect. Then you'll be ahead after this, hopefully. Stop sharing my screen. And you think you can turn off the lights? Alrighty. You're not going to be able to see me. Do we have a lamp? We don't have a lamp. Okay, I'll just turn my camera off. Go. Alrighty, so can everyone see my IDE here? Okay, perfect. Repr is mainly used for debugging and development. And then it's like the canonical representation. And str is used more for printing something. So let's go ahead and see here. Create repr versus str. All right, so let's say we want to do class. Here we do str test. And in here we have the def string. As you can see here, it's a predefined function or a built-in function. And then here, we could do something like return string. And so then if we would create s equals str test, we would initialize that. So we'd have the round brackets. And then we print s, it'll return string right here. So as you can see right here, it returns a string. Now we have class repr test, def repr. Here we would return string as well. And then we create r equals repr test with circle brackets as well. What do you think would happen if we did print r? Anyone were to guess? Would it be string? We can try. So here I commented out the first print. Here, it would also be string.
So in our class,
Mhm.
Now that I think of it.
Yeah. And so basically here is is another difference. So here, if you were to print this, it would make something like this. But if you here printed the repr of this, right? Oh, I meant to give you something else. Maybe not in this IDE. Let's try with an actual string then. Say we have the s equals string. Usually you define them differently. So repr would be more for debugging purposes. So here, if I did print str s, you'll see that it gives me string right here. But if I print the repr of s, then it gives me its inside of the single quotation marks. So they're two different definitions.
So what you would use to show like.
Yeah, basically you'd show the type of it too. And here's a different example. This would make it more clear. Import date time. This is the date time module. So today equals date time dot now. So that gives us the time right now. We would print the str of today. And here's what it gives us. It gives us the time right now and the date. But if you printed the representation or the canonical representation, it would give you more debugging stuff here. So here, we see that we also have the type of the data as well. And so this would be used more for debugging. Does that make sense? All righty. So yeah, so first it looks if the string function exists. And we can try another example as well, just to see what happens if you have both of them and you print it out. So print, or we have class comparison. We have our string, return comparison 1, and then we define the repr. This would return comparison 2. So if we printed, if we print a new comparison object, here this would actually give us comparison 1. And this would even happen if we did this the other way around. So it prioritizes string, but if you don't have that, if you don't have string, it falls back to repr right here. So those are a few differences between repr and str. Is that clear to everybody? All righty, perfect. So in this case, we can go on to our Q1. So here we have given a list of x equals x0, x1, x2, all the way up to xn, and y equals y0, y1, y2, all the way up to yn. Create a list that looks like this. X0, Y0, X1, Y1, all the way up to Xn, Yn. And here we would do this using the combine function. And right now it just has a pass, so it doesn't do anything at all. So how would we start this off? And the input would be the arrays, so X and Y.
Can I ask you a couple of questions before we? Are we assuming that they're of the same length, or do we need to test for that?
Let's assume they're the same length.
Yes, okay. And how would you like us to approach with a solution? Do we just suggest it in the chat, or?
Yeah, suggest it in the chat or out loud,
Okay,
whatever you prefer.
I guess a for loop would be nice.
All
For
right,
loop that iterates over the first list.
for
I
I and X.
I know actually if you could I mean doesn't I don't know if it should be iterative or indexing, but I guess maybe both would work with it. No, actually if you could do it in the indexing instead. So for I in range length of it minus
-1. Okay.
one. Yes, so then before that, sorry, I apologize. Before the for loop, could you create an empty list? Empty equals empty. Yeah.
Okay.
So empty dot append xi x square bracket, and then
Okay.
y dot append lex not empty dot
Sorry, what was that?
empty dot append y.
Append Y.
Square bracket,
Okay.
and then I guess yeah, return empty because it's being called over there.
Right here.
No, not here. Outside the loop.
Right here.
Yes.
Okay. Let's try it out. You guys think this works?
No.
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 Why not?
It's off the top of my. It was just off the top of my head.
Why wouldn't it work?
Oh, so you're saying it doesn't work? Thanks.
Why wouldn't it work?
I don't know. I'm not confident that much. It's just that off the top of my head, I feel like this should work. If it doesn't, then we can always check it again.
I need you to give me a clear answer. Will this work or will this not work? Just by looking at it.
Just by looking at it. Okay. I think it will.
You think?
Mhm.
All right, let's do it. What do you think? You don't think it's gonna work? Why not?
Well, it's gonna work, but it's gonna end one early.
It's gonna end one early, so you shouldn't have the -1.
Yeah.
Okay. What do you think about that? Who was talking before? Was that Jaden or
Yes, it was here.
Jaden? Do you agree with this change?
I mean, it's a good point. However, if you work on it on the X, for example, it has a length of 5, right?
Mhm.
Since we're using indexing, it doesn't have an index 5. It
Yeah.
has an index 4. So it gives you an error index out of range
Okay.
in the list. So hence why I said to do -1. So it start from 0 all the way to length of that list -1.
Okay.
That's my reason.
So you want to keep the 1?
I would like to, yes.
You'd like to keep the 1?
We can test it. We have time. We can test
All
it.
right, let's test it. So you think this is gonna work?
Why you gotta question me?
I want to
I
hear that
think so
confidence.
because combine when you say print combine xy, it's returning. It's a function call, so it goes to that function, takes in those two inputs, creates an empty list, and then for I yeah, and then it returns the empty, right? It returns the
Okay.
empty. So I think and then it prints.
All right,
Yeah, go ahead. Okay.
there we go. It did work. Congratulations.
It did not because it then so maybe he was right. The 4 and the
Oh, it
9.
actually didn't. You're right. It
So he was
didn't.
right about that.
So what do we do here?
So then get rid of the -1.
Get rid of the -1. Okay. Now it's
Maybe
gonna work.
it's not. How come? Yeah, just go ahead.
All right.
Am I missing something or? Length of X is 5, but there's no index 5. Am I missing something? Oh, yes, I am. Okay, yes, I am. I'm sorry. Yes, length of X. Yeah, it creates a sequence from 0 to length of X minus 1. I apologize.
Yes. So it's not inclusive
Yes.
on
Yeah.
the upper end.
Yeah. Sorry. You, Andrew, was it in the office there? I'm sorry. Tell him I apologize.
No, it's good. It's good. There we go. Now it works. That's question 1. Let's go on to question 2. Here, let's remove the vowels from any given string S. And in this case, our string would be hippopotamus. How would we approach this? Assuming that S is a string as input. We'll do this the same way.
Now my confidence is a little bit lower now, but can I get a crack at it? If that's okay.
Let's go.
I don't know if there's a method in the string list for not string list, for strings that checks if it's a vowel or not. So I suppose we can create a vowel string on our own, and that has a value of all the vowels in the alphabet. So A, E, I, O, U.
Okay.
And then what we can do is that we can do S lower, if that's okay, just so we can take care of the uppercase letters as well.
So just this?
I'm thinking if yeah, because no, you need to do S equals S dot lower.
S
Yeah,
equals. Why do you need to do that?
because strings are immutable, so it won't return you any. You have to assign it to another variable or itself in order to be returned something. It's not like a
Perfect.
list. Yeah.
That is correct. Strings are immutable, so
Mhm.
you can't change them.
Yeah. It needs to be assigned to something else, or reassigned to that same value.
Correct.
Another for loop would be nice. So
Okay.
this time not indexing. This time it can be in the common loop form for I in S, for example.
Okay.
If I in vowels. Oh, okay. So okay, I see now. Okay, so I did miss something again. Remove the vowels from any given string. Okay. Could you create before the for loop, could you create an empty string? So
Yeah.
again, empty equals, yes, for quote. If I in vowel, if not I in vowel, or say if I not in vowels.
If I not in vowels.
Yes.
Okay.
I want empty equals empty plus I.
All right.
And then else, if else is okay. I usually do else and then pass, but if it's extra, you can remove that.
Else pass.
Yeah.
You actually, you don't need this.
Yeah.
Because if there's no else case, it just won't do it.
Yeah. I usually so I usually do it on my own just because I like to see if and else together. I don't know. I'm an idiot. Out of the for loop, and then same edge as the for loop.
Okay.
Return empty.
All righty. Is this going to work?
For I. For I and S. Yeah, I hope so. I think so. Yeah.
You think so?
You said remove string. What is string is hippopotamus. Okay, sorry. Okay. Yeah, I think so.
Alrighty. There we go. Is that equal?
Yes, it seems so.
Let's see.
I can check. Oh, well, oh, okay. I have a feeling it's gonna. Okay.
There we go. It is. Good job.
When you do stuff like this, I feel like I have to check, oh, is this linear has to do with memory and stuff, and if it's pointing to other stuff.
All right.
So anxiety level, well, Jesus. Okay.
All right, next one. Given an array of strings, find the average string length. And then here we input the array of strings, and then we want to print out the average length, so the mean.
Okay.
How would we start this?
The average length. Okay, so in overall average length?
Overall, yeah.
Overall, okay. Okay, we can find the length of each element in that list,
Mhm.
and then add them all together, and then we can divide by the length of the list itself.
Okay, let's try that out.
Oh, yes, I'm sorry. I guess you could say total sum, for example, or total. Yeah, total sum is initialized 0. And then for I in n, or sorry, for I in n, that's the list variable parameter for I in n. Total sum equals is assigned to total sum plus length of I, len of I.
Plus len of I. Okay.
And then once we do that, we can come out of the loop. Once it's done doing that, we can do average AVG, total sum divided by total sum. Sorry, not yet. Length of n. Sorry, length of n.
Length of n.
Now, and the length of a string, to me, it doesn't sound, I guess, correct in order for it to be a floating number. The length of a string can't be like decimal or point something.
Mhm.
So in this case, we would have to use integer division. So it would give us an integer result.
In this
Total
case,
length.
it's okay.
Oh, okay.
Because it's the average, it's the mean.
Oh, okay. So, okay.
Yeah.
And then return AVG. Next line.
Turn AVG. All righty, let's try this one out. There we go. Is that correct? Let's try that out. So let's do it manually.
Okay.
So we have 5 here. 5 plus, and we have 1, 2, 3, 6. We have 9 plus
10.
that's 10 plus
12.
12 plus 9.
Yeah, and then plus and divided by 6, is it? Or 7, actually.
7 equals average length of n. Let's see. There we go. It is true. It worked.
If for question 3, if we were considering not the average to be a float value, and if we did use integer division, would we lose at some cases, would we lose wouldn't we get the wrong number for some cases? Because if it, maybe it's counting one less for the average or one, yeah, because the integer division, it counts, because if it's something like 2.5, it goes down, right? It doesn't go up, for example.
Yeah. No, it goes down regardless. So integer division always floors.
Yes,
It's also called floor division.
you're right, right.
Yeah, so I mean, if you wanted to include, if it's over 0.5, then it goes up.
Oh,
and
we
if
use
it's
if
under, then
statements,
it
for
goes
example.
down. Is that what you want to do?
No, I was just asking that if we, how would we do that? But then you mentioned that we could use like if statements.
Yes,
Some-
you could use if statements.
Okay.
There we go. And so next up, we have this question. Find the number of palindromes in a given array of strings, and how fast can you make this? So runtime is what I mean by this question.
Okay, I'm gonna dip now because this is hard now. No, I'm kidding. I'll mute
Yeah,
for
you
a
can
bit.
give it a shot.
I'll mute for a bit. I'll think about it and then I'll come back.
Okay.
Sorry, I'm back. I think I have an idea.
Okay, let's do it.
A palindrome is a word that when it's the same written like from the front. It's writ. Well, I mean, when you view it or look at the word from the from the left side and the right side, it's the same letters in order, I suppose.
Mhm.
It's a very bad way of explaining it. I'm just not trying to use like specific terms because that's gonna be used in the idea that I have.
Okay.
Okay. I guess we can make another loop again.
Okay. Four.
For I in n. If I is equal. Oh, it's counting how many? Okay, I'll get to them. If I is equal to I square bracket double colon, so colon -1.
-1.
And another colon because it's asking for an if statement. Okay. And then enter, then counter, increment counter. So counter plus equal 1. And then if you don't mind, before the for loop, initialize the counter with 0.
All right.
And then after the for loop, so the same edge as the for loop, if you don't mind, return counter.
Return counter. All right. So what is the runtime of this one?
So counter is it's obviously one assignment, so one step, doesn't take much. And the for loop, because it's a for loop, just I and n, that takes length of n, so that's all of n, that for loop.
Mhm.
And the if statement, it only does one. Well, I mean, it has to reverse it first. But then it's just an assignment. I don't think it's going to be an O of n squared. I don't think so. So
Why
I
not?
think why not? Because like it doesn't have to sort through maybe the elements in order to reverse it in this sense. I don't think it's an O of n squared. I don't think, because it has to do that statement or that comparison I equals I, and then that it does it for each element, but it only does it one time. It does have to like n of n times. And then the counter is only once again for each of them. So I believe it's O of n.
You believe it's O of n? Okay. How can we make this faster than O of n?
We can? Oh, okay.
How can we?
Make it faster than O of n.
That's correct. That is correct. You actually cannot do it faster than O of n.
Yeah, I don't
That's
like your
because-
I don't like your cunning voice. You always do that.
So that means you have to go through every single element, regardless.
Yeah.
And in that case, it has to be O of n.
Okay. 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 Yeah, that's my take. Though.
All
Would
right.
you like to test it?
Let's test it out. There we go. It's 5 palindromes. Is that correct?
1221 is a palindrome. The fourth one, that one.
It's 2.
It seems that that one as well. Yes, the next one and the next and the next. Yeah, so
Perfect.
5.
There you go. Good job. All right. Next up is question 5.
Oh no.
Given an array n, return the numbers with an even amount of digits in a list. So you
Even-
can't
okay.
convert these into strings.
Okay. Okay. We can't convert this. Okay. This one's gonna take a while.
Good. Take your time. This one's a bit tougher. Would be easy if we could convert them into strings, but in this particular question, we cannot. I can start this off. First, what we would do, we would create an empty list because we have to return a list. Says right here,
Then we go and we loop through. So for number in n. Here's what I would do. So I would create a new number which equals to the number that we're iterating through. We would say that equals that same number. And then we'd have counter equals 0. All right. Any idea what we do after this, given these new variables?
I was thinking of maybe dividing it by 10 each time. And
Okay.
every time you divide that new number by 10, you increase the counter. And then if the counter is even, then that makes it an even amount of digits.
Perfect.
So it has to, so in this case, you would have to make not another loop, but I mean, yes, I guess, no, another loop, no. No, yeah, you would need another loop. I mean, no, sorry, a while loop instead.
A while
that,
loop.
yeah, a while that number or new number is bigger than 0, or is bigger than 0, yeah.
Bigger than 0. Okay.
New number divided by 10. Divided by 10, not integer division or something. Sorry, new number equals new number divided by 10.
Okay.
And then
Alrighty.
counter, next line counter increment.
Like that.
Yes.
All
And
right.
then we would have to check. We would have to check somehow when the counter is. Okay, yeah. So outside of the while loop, yeah, right there. If counter modulo division 2 equals 0. Sorry, what are we supposed to do? Practically, do we enter the number, that value, return the numbers? Oh, okay, so the values in the list. Okay, so E dot append new number.
New number. Okay.
That's it. Yes, that's it. Oh, right. And then on the edge of the for loop, return E.
All righty. Let's see if this works. Ooh, what's going on here?
Oh, okay, so it's the even, well, not returning. Oh. Either. The number in n. Oh, sorry, append, not new number, number. Append number.
The number, okay.
Try that.
See. Oh.
So yeah, yeah, and then I noticed that issue as well because since it's returning those ones as well when it's the one string ones or the yeah 1 and 2 and even the 133 as well. Okay. What about, okay, so 591 is even, but not the next one. That one also even? Yeah, that one's even. Okay.
And then it didn't get 1333.
And it
That's
didn't
fine.
get that one. Oh. Okay,
For some
so,
reason, it didn't get 5 either, even though.
well, I mean, you know the reason, but yeah. Okay. For some reason. Sorry. Number. But how come?
Have you guys ever used the debugger for Python?
Me personally, I don't use VS Code that much. I got stuck to the Python idle because they insisted on using Python idle, but I don't. Yeah, I don't recall using debugger that much.
Here, I'll show you guys a trick that I use a lot when working with Python at work or for assignments. There's this thing called the debugger, and it exists in VS Code. If you download specific plugins,
Yeah.
I'm using PyCharm right now.
Yeah.
It super powerful in PyCharm. Reason I like it so much. Here, you would place a breakpoint wherever you want to stop the program. So here, let's just say we want to stop it at, the creation of this variable. So we click on the line right outside of the code area. And then we say, okay, here we want to debug. So we debug Q5. Sorry about that. And then it stops our program here. And so here we can see everything that is in our main thread. And it's we're in the even function right here. So if we want the whole module, we have that right here. Or if we want to go down into the even function level, we make sure we stick here. So here we have our n. This shows you the position as well as the value. Pretty cool. But another cool thing is that you can step over. So here, now we see we have another variable. After this line, we've created the variable e. And we step line by line to see, what went wrong here. So now we have for number in n. Here, number is 1 because number is 1 right here. New number equals number. So we just created, they're both equal to 1. Perfect. Counter initialized to 0. Now we head into our while loop. So while new number is greater than 0, we go, okay, new number equals new number divided by 10. So our new number right now is 0.1, as you can see right here. And so then our counter increments by 1. Now we have a 1. We go back, new number equals new number divided by 10. Now it's a 0.01.
Oh, okay. Wait, sorry. Sorry. I guess, do you have to go? Do you want to continue, or can I change the error for a sec?
No, let's change it. So the debugger is meant to basically show you what's going on in your program to help you, debug it.
Okay, so we don't want it to divide anymore when it's less than 10. I'm sorry. While new number is less than or equal to 10, then, or bigger than or equal to 10.
To 10?
Yeah, I think so. Because yeah.
Why 10?
Because even when it reaches 10, it has to divide one more time. Like, I'm sorry, I don't even know why I'm saying 10. Why am I saying 10? Yeah, I don't know. I think I don't know. I think it was first I wanted to say, because we don't want it to divide anymore when it's not less than 0, but maybe like less than 1, because it reaches the decimal numbers. We don't want it to divide anymore.
Okay, less than 1.
While
You wanna
new number
retry
is,
this?
yeah,
All right, let's retry it.
no,
All right,
at least that one worked.
a little bit better,
A little bit better.
but it has this one.
There's that one as well, okay. I mean, I could just add another condition for the while loop to check.
Mhm.
And saying, you know, while new number is bigger than 1 and the new number is not equal to 1, well, that's just a case thing. So I don't want to do
Yeah.
that necessarily. I think it's an easy fix.
Hmm.
If it keeps. It has to stop. We don't want the loop, the while loop, like execute anymore. Once it has a length of 1 in a sense. So once it's a one's number in a sense, not a 2-digit number. So
Right.
in order to check that is that we have to do. We don't know. We're not supposed to do modulo division, but oh, okay. Well, new number is less than 10. What am I doing? Yeah, yeah. Well, the new number is no. It's bigger than equal to. Bigger than equal to 10. Yeah, yeah,
Okay.
yeah, yeah. Well, it's bigger than equal to 10. Do that when it's not anymore. Stop.
Okay.
Let's
So
see if
this is gonna work.
I don't know.
Shut up.
Oh, Jesus! I ruined it. I don't know. I don't know. I'm thinking multiple places. I don't know. I'll stop.
You can keep having a try, or if anyone else wants to go, add on to this, feel free to do so.
What was the previous condition when it was bigger than 1?
Yeah, when it was bigger than 1.
Okay. Okay, I'll just see the code again, what it's doing. The number in N. One new number. Yeah. We want it to stop.
Hmm? Yeah, it's right, literally across that way.
I guess since we're dividing by 10 each time, we can say, well, new number. Why do we say?
So here, let's check what we have. We have 1,
Yes, sir.
which obviously we know it's wrong, right?
Yeah, yeah.
66, correct. We have 55. We have another 55. So that's right here. It's skipping over the 7, skipped over 2 to 5. 133 it didn't do. 1333 it did. Then next this one has 6, skipped over this one because it has 5, skipped over this one because it has 7, and then this one has 8.
8.
So
Yeah.
everything except for this one right here. So what can we do to fix that?
Like I said, I don't want to add the condition and the new number doesn't equal 1 because that's just as like a case kind of thing, like only this question. But if we want to like think about other types of values, it might not work for other values as well. So I don't want to just add and new number doesn't equal 1. That's just that's not a smart way to go about it. So it's a lazy way.
Here, let's
Oh no, why do you gotta? Oh no.
Now we have 0 and 1.
Why you gotta do that?
Let's assume these are positive values. So I won't go in the negatives, but
Oh my God.
even if we put like, say, right, that wouldn't work either.
Oh, wow. Okay. So that's a very big, I'm missing a huge thing though.
I wouldn't say it's huge, but it does affect numbers, as we can see, 1 and under.
Okay.
What can we do?
Just,
with that?
so it has to do something with the condition of the while loop.
Yes,
Okay.
has something to do with here, but how would we fix it? Would we change the condition or can we do something else?
Oh, okay, maybe. Could you try while new number? No, I don't want to. No, never mind. We wanted to. How about? Can you do test for a sec while new number bigger than 10? I would like to see what's wrong with it. Oh. Okay, so no, because right, because when it. Why does it do those ones as well?
Let's see.
But new number isn't bigger than 10. Why does it? If count. Oh, okay, okay. I see why. Because okay, because even though the new number. Oh, okay. Well, okay. So the number. So if the first index, the first element is 0, it goes through the while loop, like as in only the condition of it. But since it's 0, then since it checks 0 is not bigger than 10, it goes to the if statement anyway. So that's why. And then it says since 0 modulo division 2 is equal to 0, then it appends it. Okay. So that's not what we want. Okay. So that's not what we want. Well, new number.
So let's go back to this one because it worked pretty much fully.
Okay.
Except for this right here. What can we do here? As you can see, these ones were correct right here.
Yeah, I don't know. I don't know. I mean, you could say you could also say if counter divided by 2 equals 0 and counter itself doesn't equal 0. That's another. To me, that's another lazy way to go about it. But
will it work though?
I mean, it fixes the ones, the values. Yeah, the values that are less than 10, as in they're only 1 digit. It fixes those.
Yeah. And why is it lazy?
I not lazy. I mean, as in like it only. I feel like maybe it just fixes only one case. I don't know. Too many thoughts in my head.
What
maybe
case would it not fix?
What about the negative numbers?
Let's just assume that there are no negative numbers.
Okay. Well, I mean, even if you put in all the ones numbers, so 0 all the way to 9, it will work for them. So if you're assuming just positive numbers, then I guess I have no issue.
Yeah, then it works, and you're absolutely correct with that.
Okay.
So this is the solution.
Oh, man, that was whoever's gonna watch this after the recording, they're gonna have a laugh, I swear.
No, it's awesome. You did it.
Was there a way to, instead of incorporating the counter not equal to 0, to incorporate it in the while loop condition, or no?
Would you like to try?
Oh no. Yeah, okay. No. I meant as in no. I meant as in instead of writing new number bigger than 1, instead of testing for that, test it a different way so that we don't have to put count does not equal 0 in that if statement. That's what I meant.
You know what we could do?
Go ahead.
Say,
as long as, well, I mean, if you go back, you can't say if, yeah, you have to say,
number
yeah, is less than 10, then we don't want it to, We don't want it to go through the while loop. 10 number. If new number is less than 10.
Yeah.
Append number. But if it's less than 10, then we don't want it to append to the
Oh, right,
list,
right.
So this would be a pass then, if yeah, and then a pass.
Pass. There you go.
Oh no.
Mhm.
It's checking those again. Oh, you know what? Never mind. Let's just stick to that one. I don't want to think about it. So the if and the else can go
We can
away.
say this, look, counter equals 1. There we
Oh.
go. Right? Because if it's less than 10, you know it's going to be 1.
Ah, yes. Of course. Clever.
There you go. There's two solutions. Both of them would work.
Okay.
All righty. So here now,
Oh no.
we have some questions regarding recursion.
Okay.
Here, create a function that performs a recursive binary search. So here's, you input the list, the target number, the one you're trying to find. It's 9, even though 9's not really a thing here. You have your I and your J, which is, left number, right number.
Yes.
You've seen, you guys have seen recursive binary search, right? Or just binary search in general?
We've seen binary search in general, yes,
Okay.
not the recursive way. So this should be fun.
Yeah, let's try it out.
Okay.
And then if the number is not here, let's return a negative one. Yeah.
Okay. So we can't say something like from the beginning saying that if n not in list to return -1. You don't want us to do that, I suppose. 'Cause it's
Yeah,
not-
no.
Okay. 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 I'm a little bit sloppy with binary search. Binary search is where we want, in this case, we want it to be the first number in the list and J to be the last element in the list. And then we
Okay.
have to also have a pointer for the middle.
Mm-hmm.
Yeah, so mid equals A plus B or I plus J divided by 2. However, we have to use indexes. So we have to say list I plus list J.
So like this?
Sorry, yes. Yeah. Yeah, what am I saying? Index. Yeah, that's the one.
Are you sure it's like this?
Well, I mean, with brackets around I and J.
On the I and J, okay. Like that. There we go. That looks better.
Phew.
What do we do next?
We assume the list is sorted.
Do we assume the list is sorted? No. So we could put that.
You say you wanted a recursive method? Recursive approach?
Yes.
So then we would need to incorporate a base case in there as well.
Correct.
Okay.
What's the base case?
Recalling from the concept of binary search is when we want the loop, I suppose, because recursion is sort of a loop itself since it calls the function each time. We want that loop of sorts to stop when the beginning element, or I in this case, or well, yes, let's just say one of them, either I passes J or J passes I.
Okay, so if I is larger than 3.
Yes, if I
or yeah, it's basically that, right?
Well, I mean, we can also do it this way. If j is bigger than or equal to I, we want it to do that recursion, and then else just return -1 kind of.
Okay.
Yes.
Alrighty.
And then we have to implement the passport. Yeah.
Yes.
So in the passport, yeah, bring the mid. So line 7, bring that into pass. That's okay. Mhm. I guess. Mm, mm, okay. Okay. You wanted recursive, you said. So I guess we can just keep calling the function each time, so that maybe based on the approach we're doing, we can say that if the number is in that list, then it would become mid basically. If, like, for example, if mid is equal to our target in a sense.
Mhm.
Do you want it to, what do you want us to return? Do you want it to
Return the location.
the index? The
Yes.
index. So return LST square bracket mid. Yeah.
That would just return your value, your target.
So the index of it. Oh, so I guess you could say index list LST dot index, take the argument mid, or return mid even. I don't know.
Yeah. Yeah.
Sorry.
Are INJ indexes?
I and J are indices, yeah.
So since you said, thank you for saying that if I did LST square bracket mid returns the value, that's what we want to check for the target for the if case.
Mhm. Yeah, so we have our target already. We want to see if it's in there.
So where
if
you
it
said
is.
where you said if mid equals target, it has to be LST square bracket mid, not just the index.
Correct. Nope, because if you had it sorted, you would essentially know where it is.
But how would you know like which side to move? Your pointer to?
Oh, that's true. It does have to be sorted. You're right. I haven't done this in a while. All right. So in that case, let's assume there's duplicates. So we'll have 4 and 4.
I couldn't hear clearly. Was it what was the point?
So in here, he asked if it has to be sorted, and yes, it does have to be sorted because you have to know which side you're going to.
Okay. Okay. And then we could do an else if kind of thing. So
Okay.
the same edge as if, you can make ELIF, elif. If the value, so in this case, LST square bracket mid is bigger than the target. And then this is where we want our recursive method to be called again. So we would say return, or sorry, is it return? Yes, yeah. So we wanted to return search. That list, that is it that list? Yeah, that list again, and then target. In this case, we want it to be, so we want, now that we know where, now that we know, now if, since because of this, if the value of the mid index in a sense, in this case,
Mhm.
if it's bigger than the target, so that means it's on the left side of the middle, sorry, the right side of the middle. So we will need to check the sequence from from wherever the mid was, one after to the right of to the end of the list, basically in this case,
Okay.
or whatever that sub list is. So in this case, it would be mid, yeah, +1, because we're taking, sorry, mid -1, mid -1.
Mid -1.
Mhm.
Okay.
And then mid -1, and sorry, no, it would be mid +1 if for the, so no, over there is yeah, I'm confusing everyone. I in this case, if it was bigger than the target, then that means we want I to be oh, sorry. Okay. So if the value, yes, if the value of the mid at the index mid is bigger than the target, it has to be on the left subarray. So it's on the left side, because right now, if our value is like, if the number we're looking for is 3, for example, but our mid value is 4, then it's not going to be on the right side of the mid anymore. It's going to be on the left side. So we want the low number. So in this case, I to be I again.
Okay.
But then that one, we want it to be the one value less than mid. So the index less than mid. So mid -1 here.
Okay.
And then for the else, not the else return 1, the else on the same edge here. In this case, we don't have to check. We don't have to say, I mean, we could say LF, LST mid less than target, but that's what's implied here, since those above if statements check the other two conditions.
Mhm.
So this one, you could like write in comments saying that the condition we're looking for is LST mid, LST square bracket mid square bracket close is less than target.
All right. So it's exhaustive.
Okay.
Exhaustive means you've checked every single
Okay.
other.
Okay. Return search. So it's kind of like the opposite, the above list target, and then this would be mid +1, and then to
Okay.
J, whatever that J is.
Alrighty. What else? Or is this it?
No, I mean, no, yeah, that's it, because then it would return mid, right? Once it reaches that. If it's not there, then it would return negative.
Okay, let's see.
So in this case, yeah, number 5, index 5 is where 9 is.
It is there. Alrighty, let's try 4. 4, it says it's at 3. Okay, let's try 3. 3 is at 2. Alrighty, let's try the 1. 1's at 0. 2. 2's at 1. We check 3, 4. Now let's check 5. Alrighty, 5 is at 4. What if we had
What's your favorite number, Vlad?
137?
Is that your favorite number?
Yep,
Okay.
137. Let's see. That's at
What-
6. Okay.
What about a number that's not in?
A number that's not in it. So 100.
Yeah.
Is this a -1? Good job. Looks good.
Is this well, since it's binary search, would it be, what's its runtime? Even though if it's recursive, would it be faster than the normal binary search? Or?
What's the normal binary search?
I don't want to say it's n log n, or it is n log n. It's not all of log.
I don't believe you can
'Cause it
do
has to be
binary
so-
search without recursion.
You can't do binary search without recursion. I thought You can, it's just usually they say that binary search works really well, especially when it's a sorted list.
Mhm.
And since usually when they, when they say they sort the list first, so that itself is it's n log n. I guess
So
it's
how
n log.
would you go about making it non-recursive?
Non-recursive.
Yeah.
We would just use the one that we learned, I suppose. So we would say that I is our first index in a sense, and then that J is our last index.
Mhm.
And then, so then you have target as well as the list itself.
All right.
And then, okay, so you're given them what they are, what I and J are. Okay, so we don't have to worry about them anymore. Okay. So yeah, so now we have to incorporate the base case, right? Because the base case is when we don't want the I or the J past each other, right? So
But
in
there
this
is
case,
no base case if it's not recursive.
I know. What I meant is that we have to kind of, since we have to kind of, since we're using a loop again in order to the search, we have to stop the loop when they pass each other.
Okay.
So in this case, low, I mean I, where's the lowest number? Let's say that while that number is still less than or equal to the J, we want the loop to keep happening, for example.
Mm-hmm.
And then if that's the case, then we the same thing with mid. Mid is still I plus J less bracket I plus J is into division 2. And then and then now this is where the if statements happen. So if the value of where mid is, so if LST square bracket mid is less than the target, we would say that I is now equal to mid plus 1, because we want to, because if it's on the left side, because that if the target is bigger than our mid value, that's not going to be on the left side of the mid value anymore. It's going to be on the right side now. We know that. So we want where I is before, we want it to come the value after where the mid is. So that's why it becomes I equals mid plus 1. And an elif statement where instead, if it's the other way around, where LST square bracket mid is bigger than X, then we want the J to become the mid value before that. So it would become J would equal mid minus 1.
Okay.
Sorry, I think what you said about we can't make binary search recursively. I think I was mistaken with binary sort. So maybe that's the one that's on log n. Sorry, I misrepresent that. And then another if statement or else in this case where you said if it's the exhaustive condition where if those two cases are not correct or are false, it would check the last case where then that means that mid is equal to X, so then return mid. If it's not there at all, it would be, you would have to say that return -1.
Alrighty. Try.
Because you gave X and N, you would have to say you can change the position, the order of your parameters. In the test where you said print non-search, you have X and N. So, but over there you have I, J target list.
Mm-hmm. Okay. So let's do same order.
LST target I.
Okay.
So what was the number 3? Okay.
So 2. 5 is in 4. Perfect. Works. And then you got your 100 again. Shouldn't be in there. There you
Is the runtime still O of n in this case, or no?
go.
Would it even be O of n?
The runtime here, it's
It's not O of n because even it's not O of n. It's a bit bigger than O of n, even since the list keeps getting smaller, I suppose.
in this case, no, it's not O of n.
No. It's slower than O of n. It's not faster than O of n.
Why is it slower?
Well, I thought that maybe. I mean, worst case scenario is that it would have to.
What's the worst
Well-
case scenario for a binary search? When would that happen?
It wouldn't happen when it wouldn't happen when all the numbers are checked, because it wouldn't, since it keeps on. Oh, I mean, it is like, no, yeah, it only checks half of the list then. The worst case is that it only checks half of the list, like 1/2 of that list,
Uh-huh.
right? So it would be,
So is that O of n divided by 2?
yeah, that would be O of n still, 'cause n divided by 2
Yep.
inside the O is still O of n.
Mm-hmm.
Okay, so then it is O of n, the worst case scenario.
Hmm. But okay, let's see. So first you have,
You know, it keeps on dividing it by 2 each time, then one would say it's actually O of log n.
that is
Especially-
correct,
especially
is O of
because
log
it's a
n.
Because especially since it's a sorted list from the beginning.
Exactly,
Oh,
exactly. It's
okay.
O of log n. Because it
Okay.
keeps dividing by 2 every single time. It doesn't check half the list. It checks less than that.
Yeah.
So worst
yeah,
case is you get one of these edges.
Yeah,
Either 1 or 137, and then it has to it has to divide the list every single time until it reaches the edge. But even that will not be O of n.
it's still O of log n because it
O of
keeps
log
dividing
n.
by 2. What if the number is not in? Wouldn't the worst case be that the number given is the target given is not even in the list? Because it still has to check the edge point of that list.
Right. That is also worst case.
Although that's just, very being particularly, thinking about it particularly.
Mm-hmm.
Would the
Yes.
recursive approach be the same time
Yep.
complexity?
Yep. It would.
Okay.
Alrighty. So next question.
Oh no.
Modify vertical
Such that
it prints the numbers in reverse. So here's what happens. You have 1, 2, 3, 4, 5 as an n, and here we're doing 1, 2, 3, 4, 5. We print it vertically. What if we want to reverse though? How would we do that?
So you wanted to print 5, 4, 3, 2, 1 instead?
Yep.
Okay. Sorry, more. I don't know if this is clever or not. Since we know with the vertical function, since it where it says print yeah, that one. Because at
Mhm.
first, well, especially with the number that you have, 12,345. Instead of
Mhm.
saying print, what if we add it to a list instead? And then, because each time it's getting modulo division, modulo divided, it adds that element to the list, and then we could reverse the list and then run a loop. No, okay, that's complicated. Sorry, never mind. That's too complicated.
Yeah, let's find something a bit more simple.
Okay.
No lists. You have to use the number.
Okay, okay. Yeah. You want us to use recursion as well?
Mhm.
Oh. I don't know.
Let's try to use the debugger and see
Okay.
what it's doing. See
Okay.
what's going on. Alrighty. So as you can see, we're in the vertical function, or n is 1, 2, 3, 4, 5.
Mhm.
If n is smaller than 10, then we print n. So that means it's the last number, right?
Yes.
So that's our base case. Okay. Otherwise, we do vertical n integer division 10. What is this doing?
It's calling the function again, but in this time it takes a new argument. It has a new argument. In this
Mhm.
case, 1234.
1234. And then after this, it prints n modulo 10. Okay, let's see. Oh, why didn't it go there?
Because I think if I speak in terms of like what Python visualizer shows, I think it creates a new frame because the function vertical was called again, but with a new argument. So it has to run that function first and then print this one.
Yes,
So that function has to happen first before printing this statement.
correct.
Uh,
All right. So that happens a few times, right?
Yeah.
We're now at 1.
Okay.
That's going to print this.
Okay.
Now what happens after this?
When 1 is printed, it goes back to the previous frame when the previous function was called that, and that was when. So right now it ran its function vertical, a vertical of 1 in this case where n equals 1. And since it says if n is less than 10, which it is, it prints n. So now it goes to the previous function, which called when vertical it was 1. So but because that function was done, it goes to the next step, which is print n divided by 10 or module division 10,
Mhm.
which was 12. And then it would
Okay.
do 2 instead. It would print 2 instead. And it would repeat that each time.
All right. So yeah, it's 1, 2, and then 3, 4, 5, right?
Okay.
As you can see here.
Okay.
Okay. Now we know that that is what happens. How can we modify that? Create it in reverse. So we want to print 5, 4, 3, 2, 1 instead of 1, 2, 3, 4, 5.
Is it okay if I try something so that everyone laughs when it's false?
Go ahead.
Can you switch the positions of print n divided by 10 and vertical?
So
No. That one's okay. Just yeah, do that and then.
so why would you want to do this?
Because when we do well, I mean, it might only work for the ones place. I'm not sure, but every time, for example, in this case, again, 12,345, when that's our input again for the function reverse, it checks the if statement, the first one. It notices that it's not bigger than 10, it's not less than 10, so it goes to the else. And then it does n modulo division 10. So once it does that, it divides the number, how many times for n, but then the remainder of that. So the remainder of that would be 5 in this case. But then we wanted to call vertical again. That now it's. Did you run the function?
No, I didn't.
Okay. My whole soul came down. Vertical, and then vertical function is called again, but this time now it says integer division. Well, because the previous one was remainder division, the remainder would go away. The new input is the same number, but without its ones place. Now it's 1234, and it does that again and again, but it prints that ones place of that new number each time before calling the function again. That's how.
Alrighty. Let's see if that works.
Okay. So it was only, it only took care of one case.
Take care of one case. Yes.
Oh.
What's going on here?
This is where all the laughs come in. So just imagine some laugh factor. Just I can look at it again. Vertical. It's called again. 12 has for divider, inches division 10 is 1234. So it's thinking that when it's calling vertical again, it's thinking that it's less than 10 each time.
Yeah, so what's happening here? Why is it doing 5, 1, 2, 3, 4? Let's check again with the debugger and see.
Okay.
Alrighty, so if n is less than 10, we print n. It's not, so we go here, we print n modulo 10. That gives us a 5, right?
Okay.
As you can see here, it's a 5. Next, it goes into vertical. So what happens here?
Oh, okay. Call reverse instead.
Reverse. There we go. Let's retry this now.
Okay.
Now we have 5, 4, 3, 2, 1, and it works.
I'm gonna have nightmares when I go to sleep.
All right, there we go. Next question. Print all the numbers from 0 to n, inclusive, using the two common methods. So one would be loop print and the other one would be recursive print. So let's start off with loop print.
Okay. So for I in range from 0 to n plus 1.
Okay.
Yeah, or that print I. I remember my mistake now that was raised by Andrew, so I'm not gonna make that mistake. Hopefully, I don't know.
All right, so obviously that's gonna print 0 to n.
Okay.
Pretty simple. Now recursively, how are we gonna do that?
Okay. So no loops, no for or while loop.
No for.
No
So
for, no
this
while.
has to be the base case and the recursive.
Okay. Okay. From 0 to n, so we don't want it even n to 0 or something.
So what's our base case here?
Base case should be n in a sense.
Okay.
So while it reaches n or something. At least I think.
How would we write that out?
Oh, okay. How about this? How about we do this? Counter equals 0. Counter equals 0.
Okay.
And then if counter is is less than n. Sorry, is less than or equal to n. Is less than or equal to n. Little n. Print counter,
Okay,
and then call the function recursive print n minus one. Or sorry, no. We don't want n minus one. What am I saying? Oh man, I had a good one. I lost it. Never mind. Print counter and then counter has to be incremented somehow, so we can do counter plus one, but in the if statement again, or no, right here, yeah. Counter equals counter plus one. Oh, but then no. Because then the counter always going to become zero, then that's not good.
mhm.
Maybe because I'm thinking of the loop way and we don't want that. So then never
Yeah,
mind.
I think that's.
We
the
don't
case.
we don't want an initialized value or variable.
So let's go back. All right, let's
Okay,
restart
yeah.
this. We need a
Yes.
base case.
Yeah.
What is our base case? This tells us not to do a recursive call anymore.
Yeah.
So
yeah.
after we hit our base case, we stop.
Mhm,
What is
mhm.
that base case?
Wouldn't that base case be n though? Because we don't want it.
Right, but how do we write that out?
Oh, okay. While loops are not allowed either, or
While loops are not allowed, only
are
recursive.
not allowed? Okay. How do we write out that we don't want it? How do we write that we don't if something equals n? What is that something? Sorry about that.
No problem.
Okay.
Think about how we did vertical.
Could you go back to vertical then? That's okay.
Sure.
Okay. If our base case is n, then maybe could have a, we don't want n to change. Okay, we don't want n to change. Maybe we could store the value of n at a temporary variable. So say like temp is assigned to n. And then,
Mhm.
oh, no, never mind. Oh, we don't want it that way either. I don't know.
Alrighty. I'll give you a hint. If n
No.
equals 0.
But we don't want it to print from 0. We want it to print from 0 to n, right? Not n to 0.
Correct. That's correct. But think
Yeah.
about vertical, right? Oh, you got it?
Oh, okay, so they can go.
Think about vertical. How we could change the order of what they're printed, even though they go the same way. Just by changing the order of 2 lines.
If n equals 0. Okay, if n equals 0, print n. How about if we try this print n?
Uh-huh.
And then else call the function recursive print n minus 1. I'm not sure if this is gonna work.
Alrighty, let's try that. Oh, what's going on here? It's
Oh,
only printing 0.
okay, then never mind. Okay. Maybe add another, but we don't want it. And the line after recursive print, maybe say, either say print. How about if you do print recursive n minus? Would that work?
Let's see.
Oh,
Oh, it's
none.
giving us a bunch of nuns. Why is this none?
Because it's returning none. That's
Yeah.
Okay.
Can't do that. You're very close.
I don't want to say print n again. That would be weird. No.
Would that? What if we tried it? Oh,
What? Get out of here, man. I don't want to do this anymore. What the? I'm not using an IDE. I'm trying to do it in my head. That's why I'm
yeah.
literally.
There we go. It worked. What if we want to do it backwards?
Oh no.
Backwards? Why don't we just do this?
Oh,
Boom.
okay.
There we go. Worked.
Mm.
Perfect. Now, last question of the night.
Oh no.
Find the
Factorial.
factorial of a number n. N is greater than 0 using the two methods. So n
Okay.
cannot be 0 or less. So first method is the loop factorial. How would you do this? And Andrew, if you want to get in on this, you can too. If you want to get in on this, you can as well.
So we can first initialize a variable, the value of 1. Actually, no. It may. Oh, n is bigger than 1. Okay. N is bigger than 0. Okay, so we don't have to
Yeah.
check that case. Result equals 1.
Yep.
And then for I in range, do we want range? Yes, we want range. For I in range from not from 0, from I guess 2 in this case, from 2 to 2 to n plus 1. Find the factorial of a number n. Yeah, then do result equals result times I. So it does 1 times 2 first and 1 times 3, hopefully. Yeah.
Mhm.
And then return a result.
All right, let's try. There we go,
120.
120. That's
Is it
correct.
because n is 5?
That's correct.
Okay,
Yep.
yeah, okay, I didn't see that.
5. So here, what if we do 1?
1. Okay,
This a 1. What if we do 2?
good.
Gives us a 2. Okay.
Recursive factorial. Okay.
And then 3. We get a 6.
Okay.
So it works out. Now, recursive factorial, what is our base case here?
Base case.
When do we want to stop?
We wanted to stop, yes, when we reach that number, right?
Mhm.
When we reach that number. So if if n okay, if n I guess we could do that. If n equals 1, if n equals 1,
Okay.
equals 1, we don't want it to stop ourselves, but I guess we could say result times 1, maybe not result times n, perhaps. No. Is it a good idea to initialize a variable here as well, or no? It's not needed.
1 sec.
Sure.
Okay. No, it's not needed.
Not needed, okay.
No. If n equals 1, what do we do?
I guess we could return, if n equals 1, we could return n. Because we will
Return
leave.
n. Okay.
And then if it's not, if n doesn't equal 1, we could do return n. But do we want it just to return?
So we have our base case, right? Now we need the recursive call. What do we do with that?
Yeah, okay. So we would have to keep multiplying it by a number. But if we want, since we're saying the base case is 1, we're checking that if n equals 1, so then that means every time we call our recursive function, we want it to decrease it with we want to pass an argument with a decremented value of n. So how about if we do return n times in the recursive underscore factorial n minus 1.
N minus 1. All right. Let's try that.
5, yeah. So if it's 5, it's
5 and 5. Boom. It works.
That's it.
That's it.
I should have come up with that sooner. I don't know. I kept on thinking about storing it in another variable, like
Yeah.
but then you mentioned that it's not necessary, so then I didn't know how to how to operate without one. So
that's the difficulty that a lot of people face with recursion.
Recursion,
Have
yeah.
to think in a slightly different way.
Yeah. We're so used to non-recursive approaches so
Exactly.
far. Yeah. Okay.
And so the idea of passing data from one frame into another is
That's
a bit
what
difficult.
recursion. Yeah.
Yeah.
Okay.
But yeah.
What's the
those
reason?
are all the questions.
What's the reason that you mentioned that about what's the error for the recursion that it reaches when it reaches a certain number of times that recursion happens, the program or the Python compiler crashes? What's the reasoning for that? Is it for safety or?
Yeah, it's basically you'd run out of memory.
Oh, okay. So
So
it depends, because the Python even for something like such as Python visualizer, it worked as well, that it crashes when the number of recursion steps was large enough. In this case, I believe our professor mentioned like 1,000 times. Does it
Yeah.
depend on the compiler, or is every Python compiler
Every Python, but
has the same maximum recursion depth? for
it
example?
does
Okay,
by default, yes.
okay. Well, I mean, there you go.
It's usually 1,000.
Usually 1,000.
But what you can do here is you can change that. So you can import system, and then you can
Okay.
do system dot get recursion limit that gets it for you. But then you can do system dot set recursion limit, and then you can set that to more than 1,000. So
Oh, okay. So our computers, compilers are not stupid. They're just set to a default number for the
yeah,
recursion.
they're set
Okay.
to a default number.
Okay.
So if you need more, you can do more.
So of course, why would a computer be stupid? He's just not. He's just doing what you're telling him.
Exactly.
Never doubt a computer.
Never
Sorry
doubt
about
a computer.
Okay, guess that's it.
Yeah, that's it. Are there any more questions? Any of you?
I don't have any other.
Zero. Yeah. That also gives you this. So in this case, you can say, you can have multiple base cases as well. So if you want to include zero here, you can say else, if, or elif, and equals zero.
You can
Right.
return one, right?
And one. There you go. And then if you have 5, 120 as well. You can always have multiple base cases, and you can always have multiple recursive calls as well, as we've seen previously. So here. And then this gives you multiple base cases as well.
Okay.
All righty. Is there anything else?
I suppose not, but I would really like a copy of those. Maybe,
Copy of this? Sure thing.
as a memory for myself that I guess I managed to do it with you guys.
Yeah. Okay. Do you want a copy as well, Andrew? You got it? Okay. Awesome. Well, let me just zip that up quickly. And I will send that right over in the chat. And then there's a few other answers there as well, at previous answers.
Oh, okay. Are there better ways than what we did today?
There's
question?
different ways. There's
There's
different
different ways. Okay.
I have them in case. But I always like going through and seeing what people come up with.
Yeah. Okay. All right. I guess.
Ready. So I'll send that. That is sent. And yeah, you can always message me if there's anything. I'm in the site Discord server. And my name is Vlad.
Yes, the
Pretty-
great Vlad, of course. Okay. Thank you
Alrighty.
so much. Thanks,
Yeah.
Vlad.
Good luck on your exam.
Thank you. Also, you,
you
good
later.
luck on your exam.
Thank you.
Bye-bye.
Bye.